Standard 10 Maths Chapter 8 Introduction to Trigonometry, and we are into the 6th session. In the previous session, we learnt how to find the trigonometric ratios, the values of trigonometric ratios when two sides of a right triangle are known or one side and one angle. Specifically, it should be 30 degree, 45 degree or 60 degree. That is known. Then you can easily find out all 6 trigonometric ratios. We continue with type 1, finding trigonometric ratios or value of expression or prove that. Alright, this prove that is very simple. Okay. So we move on to the next type, subtype, and it is 1.3. When value of any one trigonometric ratio is known, you have value of one trigonometric ratio and you have to find the value of remaining 5. See the first example here in type 1.3. Sec theta is root 2. Yes, out of 6 trigonometric ratios, sec theta is one of them. Correct? And the value of sec theta is given. You have to find the values of remaining 5 or any 2 as asked. Okay? Chaliye. We'll find all 5. I'll find 2 for you. Remaining 3 you can find. Okay. Now what to do? Of course, I'm going to draw, okay, solution 1. I'm going to draw a right triangle. Correct? Let's say it is ABC. Theta is the angle. So any one A or C, I'm going to call it theta. Now your target is to find values of trigonometric ratios other than sec theta. मतलब बाकी के 5. So that means you should know the value of all 3 sides. Oh God, value of none is there. हमारे इंफॉर्मेशन में एक भी साइड की वैल्यू नहीं है. तो है क्या? The value of sec theta. So definitely you are going to exploit this condition. ये कंडीशन को बराबर एक्सप्लॉइट करना पड़ेगा आपको. And find the value of all 3 sides. हमें तीनों साइड की वैल्यू ढूंढनी पड़ेगी. Fine. See the trick. Sec theta is equal to root 2. Sec theta is equal to root 2. Therefore, चलिए, we'll use the definition. Ka, so, tova. This is cos, उसका reciprocal sec sine, उसका reciprocal cosec tan, उसका reciprocal cot. The value of trigonometric ratios given to you is sec theta. So choose the sec. By definition, what is sec theta? Hypotenuse upon adjacent. So, okay, with respect to theta, this side is opposite. Hypotenuse, as always, side opposite to right angle. And the remaining side is adjacent. Okay? So, what is sec? Hypotenuse upon adjacent. Hypotenuse is AC and adjacent is BC is equal to root 2 upon 1 by definition. By definition. Children, यहाँ direct मैं कुछ दिखाता हूँ, but exactly how you get that, you see. AC upon BC is equal to root 2 upon 1. Alright? So you may take AC upon root 2 cross multiplication. Correct? Is equal to BC upon 1. And say this 2 ratios is equal to K. AC upon root 2 is equal to BC upon 1 is equal to K. Suppose. Correct? Now using the transitivity property. Therefore AC upon root 2 is equal to K and BC upon 1 is equal to K. This gives AC is equal to cross multiplication root 2K and BC is equal to 1K. 1 into K is K. But instead of doing that, straight away you can say, see children, this step is very important. This step is very important what I am doing. From here you may write directly. Let AC is equal to root 2K. I am using that unknown K. Then, if AC is root 2K, then what is BC? 1K. then BC is equal to 1K. So you can write only K. Correct? Okay. This is the result 1. Alright, children. Now see, you got the two sides. Though they are in terms of K. AC. I'm going to write here. What is AC? Root 2K. What is BC? K. Using Pythagoras, find out the third side. By using Pythagoras theorem in triangle ABC. Bolo, AC square is equal to AB square plus BC square. AB square plus BC square. Therefore, is AC available? Yes. Root 2K. So that is root 2K whole square is equal to AB. No, it is to be found still. Plus BC. Yes, it is K. So K square. This gives me 2K square. Bring this K square on one side. K वाला बदा सगा संबंधी ने एक बाजू बेगा करो. Because you want to make AB subject of the formula. That is equal to AB square. Therefore, K square is equal to AB square. So taking square root on both sides. Therefore, K is equal to AB. i.e. AB is equal to K. So this one is K. We are done, children. Now you can find any trigonometric ratios. Definition. Now, cos theta is adjacent side upon opposite. Remember that. Adjacent is BC. Hypotenuse. Sorry. Cos theta is adjacent upon hypotenuse. So BC upon AC. BC upon AC. BC is what? K. AC is what? Root 2K. K gone. Actually K upon K is 1. So that is 1 upon root 2. Therefore cos theta is equal to this. Chaliye, I straight away find tan theta. Tan theta is opposite upon adjacent. Opposite is AB. Adjacent is BC. AB upon BC. That is. What is AB? K. What is BC? Root 2. Sorry, BC is also K. Yes, K upon K is 1. Therefore, tan theta is equal to 1. So, I just found two ratios. You can easily find the remaining three also. You have to just use the definition. Got that? Sure? Good. Now, we move on to the second one where tan theta is given 4 upon 3 and we have to find the remaining 5. Okay? Children, instead of taking theta everywhere, I'll just change the angle and use another Greek letter alpha. Okay? Let's see Greek letter alpha. I'll just change this theta to alpha and this one to beta. Okay. So, what is the situation? You know the value of tan alpha. Out of 6 trigonometric ratios, you know the value of one trigonometric ratio and that is tan alpha, which is 4 upon 3. And you have to find the values of remaining 5. Yes. Easy. A, B, C. Okay. This two are acute angle. Anyone can be taken alpha. Let me take this alpha this time. With respect to alpha, this is opposite side. As always, opposite to right angle is hypotenuse and the remaining side becomes adjacent. Okay? Come on. Now, let's see what is given. We have to exploit this condition. Tan alpha is equal to 3 upon 4. Given. Therefore, tan alpha, with respect to alpha, this is opposite and this is adjacent. So, BC upon AB. BC upon AB is equal to 3 upon 4. By definition. Yes, what you can say? देखा था ना हम लोगों ने? Direct लिख दो. let BC is equal to 3K, then AB will be 4K. Correct? Let me put the values. AB 3K, or sorry, AB is 4K and BC is 3K. Use Pythagoras and find out AC. Using Pythagoras theorem in triangle ABC, AC square is equal to AB square plus BC square. AC this time is not known, so equal to AB 4K square plus BC 3K whole square. 4 square is 16, K square is K square, 3 square is 9, square of K is K square, total 25K square, and that is beautiful number. Yeah, beautiful right hand side, taking square root on both sides. Square root of AC is AC, square root of 25 is 5, and square root of K square is K. So you got this also 5K. So value of all three sides are known, 3K, 4K and 5K. And after all, trigonometric ratios लेते हुए K तो cancel ही हो जाएगा. So you get the value. Now, let's find out cosec alpha. पांचों ढूंढना है, लेकिन I will be finding only two for you. Cosec, that is hypotenuse upon opposite. Hypotenuse AC upon opposite, this BC. Hypotenuse is AC, opposite is BC. Sorry, yeah, cosec is hypotenuse AC upon opposite BC. That is good. Now AC is what? 5K. BC is what? 3K. So that is 5 upon 3. Cosec alpha is 5 upon 3. Okay, children? Understood? Then what do you want? Alright. Cot alpha. Cot alpha with respect to angle alpha is adjacent upon opposite. So AB upon BC. AB upon BC. By definition, you may write that. Here also by definition. Alright. Now AB is 4K. BC is 3K. K upon K is 1. That cancels, you can say. So therefore, cot alpha is this. So remaining 3 also can be found because 1 is already given. Tan alpha is already given. Yeah. What is tan alpha? 4 upon 3. What is the reciprocal of tan? Cot. What is the reciprocal? If you use interrelationship, then if tan alpha is 4 upon 3, then cot alpha is, see some mistake we have made here. Cot alpha is adjacent upon opposite. Tan alpha is opposite upon adjacent. That is true. So where we are getting wrong? Tan alpha is 4 upon 3. Okay, children. See, I've made this mistake here. It's 4 upon 3 and I wrote 3 upon 4. Alright, I'll change it quickly. Change it. So this becomes 4K, this becomes 3K. Yeah, this will be 3 and this will be 4. So this will be 9 and this will be 16. But the AC is going to be the same. Yes, now it tallies. Okay, okay. Cot alpha. Please. Cot alpha is AB. Now AB is what? 4K. I have to change here also, no? What is BC? BC is 4K and AB is 3K. Alright? So cot alpha is AB upon BC. Alright? What is AB? 3K. And BC 4K. KK cancels. 3 upon 4. Thank God we saw that and found our mistake. Alright, tan alpha is 4 upon 3. Reciprocal of tan is cot. So cot alpha is 3 upon 4. Getting that? Cot alpha is 3 upon 4. You can change here also. Cosec. BC is going to be 4K. So it will be 5 upon 4. Alright? Yeah. If we were in the classroom, you could have shouted and said, "Sir, it is 4 upon 3 and not 3 upon 4. Yes, that is one more advantage, okay, of doing the work in your presence. Fine. But I hope you understood it. Now we will see sine B. So, trigonometric ratio, one value is given and that is of sine beta. Alright, sine beta. And we have to find the value of remaining. Okay? Fine, as usual, I'm going to draw right triangle. I'm changing the name of the triangle PQR instead of ABC. As I told you in 10th standard, only right triangles, trigonometry of only right triangles we are going to see. Yeah? Okay, I'll call this as beta. With respect to beta, this is opposite side. Right angle ये है तो सामने hypotenuse और remaining side is adjacent. Alright, let's start. Sine beta is equal to root 3 upon 2 by data, or given you can see. Therefore, sine beta, what is sine beta? Opposite upon hypotenuse. Opposite PQ upon hypotenuse PR is equal to root 3 by 2. Let PQ is equal to root 3A. I use small a instead of K. Normally you take K, alright. Then, just for a change, PR, it's down PR. Then PR is equal to 2A. Using Python, so I'll write that. PQ is 2A. Sorry. PQ is root 3A. And PR, it's here 2A. So we'll have to find out QR. By using Pythagoras theorem in triangle PQR. PQR. बोलिए. PR square is equal to PQ square plus QR square. PR is known, therefore 2A whole square plus, is equal to PQ square, that is root 3A whole square plus QR square. We need to find QR. 4A square is equal to 3A square. Square root of root 3 is 3 and square of A is A square plus QR square. 4A square minus 3A square, we have taken this on the other side, is equal to QR square. So therefore A square is equal to QR square, taking square root on both sides. Therefore A is equal to QR, i.e. QR is A. So this is also known now QR. You can find any. बताइए कौन सा बच गया है? All right. Yeah, I'll take cos beta. That is adjacent upon hypotenuse. Adjacent is QR and hypotenuse is PR. QR upon PR. What is QR? A. Upon what is PR? 2A. So A gone, 1 upon 2. That is cos beta. And cosec beta is equal to hypotenuse upon opposite. Hypotenuse upon opposite. PR upon PQ. PR upon PQ. You can write by definition. Alright? PR upon QR. PR is 2A. QR is A. There you are. 2. So what is cosec beta? So like that you can find the values of remaining trigonometric ratios. I hope you have understood. Children, एक बात बताना चाहता हूँ यहाँ. ये जो चीज है, alright, say suppose कोई भी ratio, x is to y is equal to 2 is to 3, ऐसा कुछ हो. So you can say x upon y is equal to 2 upon 3. मैंने को क्या बताया? Let x is equal to 2k. Then what is y? 3k. Why we are doing that? Let's try to understand. वो ऐसे क्यों करते हैं हम लोग? समझो. Sometimes in this chapter, some teachers will teach you x equal to 2 ले लो और y is equal to 3 ले लो. Yes, you can take that and it works well in this chapter, but it won't work in general. Yeah. So you have to take in this way only. Okay. Q reason I am showing you. Chalo. X. Okay. Here x equal to 2 and y is equal to 3. आप ले लो और रेशियो देख लो, x upon y is equal to 2 upon 3. Yeah. Now I am taking another multiple of 2. 2 2s are 4. So second multiple of 3 9. Here x upon y ले लो. Second multiple of 3 is 6. So x upon y will be 4 upon 6. 2 2s are 2 3s are. So still the ratio is 2 upon 3 only. Okay. Third multiple of 2 is 6 and third multiple of 3 is 9. So I take that value. Still x upon y is equal to 6 upon 9. 3 2s are and 3 3s are. The ratio is same. So x is to y is 2 is to 3. Here x is to y is 2 is to 3. And x is to y is 2 is to 3. When x equal to 2, y equal to 3, x is to y is 2 is to 3. When x equal to 6 and y is equal to 9, x is to y is 2 is to 3. When x equal to 6 and y is equal to 9, still x is to y is 2 is to 3. So this ratio remains the same. So if ratio is 2 is to 3, then what is x? It can be 2, it can be 4, it can be 6. Then the corresponding value of y can be 3, 6 or 9 respectively. So values of x cannot be fixed, but we know the value of x. 2, 4, 6, next will be 8, 10. These are multiples of 2. And how do you represent multiple of 2? By writing 2k. Multiple of 3? By writing 3k. Are you getting me? Multiple of 2 is 2k, multiple of 3 is 3k, multiple of 5 is 5k, multiple of 7 is 7k, where k is any natural number. Take k equal to 1, 2, 3, 4, anything, and you get the multiples of that number. k1 liya, so 2 1s are 2. k2 liya, 2 2s are 4. Next multiple. k3 liya, 2 3s are 6. So 2, 4, 6, you get the multiples. I hope you understood. Good. So we move on to the next subtype, and that is 1.4. A subtype 1 here. Alright. Now one side and relationship between any two sides in which known side is included is given. Yes, this line I'll explain while I draw the figure. See, this is the detail given. In right triangle ABC, right angled at B, BC is 12. So that one side is given. And the relationship between two sides. Relationship between two sides. In which known side is BC, that is involved. Relationship में जिस साइड की वैल्यू दी है, that is involved. Okay? इस situation में you have to find the trigonometric ratios. Alright? चलिए. Yeah, I'll draw the right triangle. This is, yeah, right triangle ABC, क्योंकि नाम जो है वही देना पड़ेगा. Alright? And you have to find cos A, sin A, cot A, tan A, sec A and cosec A. यहाँ थीटा नहीं दिया है. Here angle A. So we'll consider this. This is angle A. उसका नाम थीटा बीटा कुछ देना नहीं है. Angle A. With respect to angle A, this is opposite side. ये right angle है तो उसके सामने की side hypotenuse. And the third remaining side is adjacent. It is adjacent to angle A. ये सामने है और ये adjacent है. ये भी adjacent है, but it is opposite to right angle, so it is called hypotenuse. Chal. Now what to do? Yes, put the value. You know BC, so put the value. I'll write here. BC is equal to 12 and call it 1 by data. By data. Also, AB plus BC is equal to 17 by data. Therefore, AB plus, yes, what is BC? 12 is equal to 17 by 1. Therefore, AB is equal to 17 minus 12. Therefore, AB is equal to 5. So I'll put the values. BC, जो 12 दिया, AB from the condition we got 5. Now third side is required. So you can use Pythagoras. Children, are you getting me? Using Pythagoras theorem in triangle ABC. ABC. AC square is equal to AB square plus BC square. Now AC square is not known, so equal to. This is pi square. Can I write directly? 25. 12 square, 144. Total 169. That is beautiful perfect square number. Taking square root on both sides. AC. Square root of 169 is 13. So you got this 13. अब जो ढूंढना है ढूंढ लो. Now I'll find only 2. Alright. Cos A. Adjacent upon hypotenuse. Adjacent is AB. Hypotenuse is AC. So AB upon AC. AB is 5. And AC is 13. That is cos A. ठीक है? And tan A is equal to opposite upon adjacent. BC upon AB. BC upon AB. BC is 12. BC is 12 and AB is 5. That's it. Reduced form में ही है. So this is tan A. Got it? And you can find out remaining if you want. Okay? So see, please enter everything in your notebook. Alright? Say suppose if I forget to tell you in this video, okay, copy all this in your notebook. Some children, they are sending me message on WhatsApp. Sir, do we have to write in the notebook? I don't have to tell you every time that this is what you have to enter in your notebook. Today you will get exercise as well to do. Okay? Alright, then let's move to next type. Subtype 1.5. One side and relationship between remaining. I put remaining circle. In the previous one side and the relationship between remaining, not remaining sides, two sides in which one known side was involved. Here that known side is not involved. Let's try to understand with figure. In right triangle OPQ, right angled at P. So let me draw right angle triangle. It is right angled at P. Okay. Now let me say this is O, this is Q. Okay. So in right triangle OPQ, OPQ, right angled at P. OP is given. What is OP? Where is OP? Here. That is 7. So now relationship between the remaining two sides, that is PQ and OQ, OQ and PQ, that is given. In the previous example, this side was involved. Relationship between OP and OQ or OP and PQ. That was easy. This is going to be a little bit tough. Let's see. Okay. So I'll start with given OP is equal to 7. Call it 1 by data. Also, what else is given? OQ minus PQ is equal to 1 by data. Children, now both are not known. So for one I have to put X and other I have to put Y. That is what I have to do. But then I am involving two variables. Jitne variables बढ़ेंगे उतनी तकलीफ बढ़ेगी. Are you getting me? So I need only one variable. So I am going to put only for PQ. Let me put for PQ. Or you can put for OQ also. So OQ remains same. OQ remains same. Sorry. Minus. In place of PQ, I am putting X is equal to 1. Where PQ is equal to X. Suppose you have taken PQ is equal to X. So I am going to write here PQ is X. Chaliye, take X on other side. Therefore, OQ is equal to 1 plus X, i.e. OQ is equal to X plus 1. Commutative property, correct? So this is going to be X plus 1. Okay. Right? Now, using Pythagoras, you will have to find the value of X. Kaam pura nahi hua. Your work is not over because this is X and this is X plus 1. and this one is not in terms of x, वो k cancel हो जाता था, a cancel हो जाता था, ऐसे नहीं होगा. So you have to find the value of x, and for that you have Pythagoras. Using Pythagoras theorem in triangle OPQ. OQ is the hypotenuse, so OQ square is equal to PQ square plus OP square, PO square. What is OQ? That is x plus 1 whole square. PQ, that is x whole square. OP, that is 7 whole square. Now this is where you have to expand. A plus B whole square. How do you expand? Some children write A square plus B square. This is how some children expand. But the expansion identity is what? First term square plus 2AB plus B square. So apply that. First term square, that is x square, plus 2 into first term into second term. So 2 into x into 1. 2x plus 1 square, that is 1, is equal to, here it's only single term, x square plus 49. Alright. x square on opposite side gone. क्योंकि इसको लेफ्ट हैंड साइड पे ले आते तो माइनस एक्स स्क्वायर प्लस एक्स स्क्वायर माइनस एक्स स्क्वायर ऑन द सेम साइड कैंसल्स and the same terms cancel on the other side. चलो, therefore 2x 1 को वो बाजू ले जाओ 49 minus 1, so 2x is equal to 48. Therefore x is 48 divided by 2. Therefore x is equal to 24. So this is 24. This is 24 plus 1, and that is 25. So 3, 24 and 25. Sorry, 7, 24 and 25. Those are the values of three sides. Now you want to find sine theta. Now sine theta is opposite side upon hypotenuse. Yes, with respect to n, not theta. This is q. This q. So this is opposite. This is always hypotenuse to the right side, and this is adjacent. So what is sine q? Sine q is opposite upon hypotenuse. So OP upon OQ. OP upon OQ. What is OP? OP is here 7 upon OQ here, that is 25. Therefore sine Q is equal to 7 upon 25. Same way you can find out cos. That will be adjacent upon hypotenuse. So that is 24 upon 25. Got it? So now we move on to type 1.6. Children, see. I'll read this later. Triangle ACB is right angled at C. So let me draw right triangle. It is right angled at C. So you can take this A, this B. Alright. AB is equal to 29. Yes, that is hypotenuse. 29. Hypotenuse. Right. BC is 21. This one. And angle ABC, that is B, this one, is theta. So with respect to theta, this is opposite side, वो hypotenuse है, और ये adjacent है. Sir, ये तो सम आ गया, when दो sides दिए थे, तीसरी side ढूंढ लो using Pythagoras, and then find any of those 6 trigonometric ratios. Yes, correct. But here you have to find the value of expression. So that is slight change. Till now you were finding trigonometric ratios. Now you are going to find what is the value of expression. And the expression contains cos theta and sin theta. वो आपको ढूंढना है. Okay. As earlier, हम लिखेंगे AB is equal to 29, BC is equal to 21. 1 by data. लिख भी देते हैं. यहाँ लिख लिया है AB and BC. Now using Pythagoras, let's find out AC. Using Pythagoras theorem in triangle ABC. Hypotenuse is AB. So AB square is equal to BC square plus AC square. BC square plus AC square. Therefore, what values are available? AB, yes, 29, so square. BC, yes, 21 square plus AC, which we will have to find initially, correct? Use that trick, a square minus b square. Therefore, 29 square minus 21 square is equal to AC square. Therefore, 29 plus 21 into 29 minus 21 is equal to AC square. Therefore, this is 50 into 8 is equal to AC square. Taking square root on both sides. Now, there is a nice trick to find square root. Isko multiply mat karo. First, you find the prime factors of 50. 2 25s are, 5 5s are, 5 1s are. Okay? I won't write 1. I will continue. 50 multiplied by 8. So we have 8 and find prime factors of 8. 2 4s are, 2 2s are, 2 1s are. And then look for the pairs. You got pair of 5, you got pair of 2 and one more pair of 2. Therefore, yes, 2 pairs of 2. So I will take 1 from each. And pair of 5, I will take 1 5 from that. Square root gone, i.e. AC is equal to 20. 4 5s are 20. So AC is 20. Now you find out what is cos theta, sin theta, and then put the values. Alright? Now, cos theta is equal to, or you can write now, by definition, cos theta is equal to and sin theta is equal to dono. Cos is adjacent upon hypotenuse, that is BC upon AB, BC upon AB, and BC is 21, AB is 29. So 21 upon 29. And sin theta is opposite upon hypotenuse, that is AC upon AB, AC upon AB, and that is 20 upon 29. 20 upon 29. Is that clear? Okay. I'll remove this part now. I'll just remove this figure. My first target is to find the value of cos square theta plus sin square theta. Let's take it. Thus, now cos and sin, both the values are available. So, thus, cos square theta plus sin square theta, which I am supposed to find. Yeah, cos square. So, square of cos. What is cos theta? 21 upon 29. Plus, square of sin. What is sin square theta or sin theta? 20 upon 29. Okay. Now, square of 21 is 441. What about square of 29? 29 into 29, 0, 18, 5, 81, 8 and 26, 1, 0 and 8. 8 plus 841. Yeah, this is up, 841 denominator. And this is 400. 20 square is 400. And 29 square we have just found. Oh, like denominator, that makes your work easier. Up 441 plus 400. 441 plus 400 is 841 upon 841. And that is 1. So what is the value of cos square theta plus sin square theta? 1. Similarly, you can find out the value of cos square theta minus sin square theta. Alright. And cos square theta minus sin square theta, that is equal to cos square 21 upon 29 whole square minus sin square. So let me put square, value of sin 20 upon 29. This is 441 upon 841 minus 400 upon 841. Yeah, like denominator 841. So this is 441 minus 400. This time it is minus. So 41 upon 841. That is the value of cos square theta minus sin square theta. Got it, children? So now initially we were finding trigonometric ratios. Now we are finding the values of expressions. But to find the values of expressions, we need to find the required trigonometric ratios. In this case, cos theta and sin theta. Children, don't be scared. So many types. No. All these types are under title type 1. type 1.1, 1.2, 1.3, so many, you will think so many. No, 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 don't get scared with that. Okay, they are simple. Two sides are given. Two sides are given, so you can find out third side. One side and one angle, that specifically 30 degree, 45 degree or 60 degree. And as I said, you will not find that question in any of the reference books as well. Textbook में तो है ही नहीं, reference books में भी नहीं मिलेगा, क्योंकि वो केस कौन सा होगा? Trigonometric ratios of special angle वाला. That's why. Okay. Then one angle, one side, and the relationship between the other two, remaining two, or one side and relationship between two, in which the known side is involved. वही है, और कुछ नहीं. Okay. Now we'll continue. Okay, this sum that we did was illustration 3 from textbook. Okay, so illustrations are also involved here. In the previous one, it was illustration from number 5 from textbook. Okay, so we move on. Conditions, given conditions, information same आएगी, लेकिन अब हमें ढूंढना है value of expression. उसके बाद हमें कुछ prove भी करना पड़ेगा. All right. Alright, so the last subtype under type 1, and that is 1.7. One trigonometric ratio is given and you have to prove that. See, look here. 3 cot A is equal to 4. Hey children, ये तो कुछ उल्टा पुल्टा दिया है. Cot A नहीं दिया है. It is 3 times cot A. Yeah, you can make cot subject of the formula. So what is cot A? 4 upon 3. सीधा कर लो. Correct? So you have value of cot A. One trigonometric ratio is known, and you have to prove left hand side is equal to right hand side. Yes, ये prove करने के लिए कौन से trigonometric ratios की जरूरत पड़ेगी? tan, cos and sin. Tan A, sin A and cos A. All right, let's see. I'll draw the right triangle. This is angle A, that has to be acute, so I'll say that A, B and C. Alright. With respect to this angle A, this is opposite side, ये तो hypotenuse fix है, and this is adjacent side. What we have here is 3 cot A is equal to 4 by beta. Therefore, cot A is equal to 4 upon 3. Therefore, cot adjacent upon opposite. So, AB upon BC. AB upon BC is equal to 4 upon 3. Alright? Boliye, let AB is equal to 4K. Then BC is equal to 3K. Correct? AB 4K, BC 3K. So now you need to find AC. We'll use Pythagoras. Using Pythagoras in triangle ABC. बोलिए, AC square is equal to BC square plus AB square. Correct? Now AC we do not know. So equal to के नीचे equal to. BC square will be, I'm writing directly, 3K का whole square, 9K square. Square of 4K, 16K square. That gives me 25K square. That is good sin, good picture. Therefore, AC square. Taking square root, therefore AC is equal to square root of 25 is 5, square root of K is K. So this is 5K. Now you need tan A, cos A and sin A. Now, tan of angle A. Opposite upon hypotenuse. This is opposite upon adjacent. That is BC upon AB. That is 3K upon 4K. And that is 3 upon 4. Cos A, adjacent upon hypotenuse, that is AB upon AC, that is 4K upon 5K, and that is 4 upon 5. and sine of angle A, that is opposite upon hypotenuse, which is BC upon AC is equal to 3K upon 5K, and that is 3 upon 5. So all the values are available. I haven't got any result. So let me say this is 1. Now I pick up left hand side. Left hand side is 1 minus tan square A upon 1 plus tan square A. कुछ करना पड़ेगा यहाँ. See, I am using bracket. 1 minus, what is tan A? 3 upon 4. So what is tan square A? 9 upon 16. यहाँ 1 upon 1 लिख देता हूँ. So for 1 I wrote 1 upon 1 minus, so minus tan square. So tan A is 3 upon 4. So 3 upon 4 का square this. Instead of writing this whole upon, I am putting division sign. And in the next bracket, similarly, 1 is 1 upon 1 plus tan A is 3 upon 4. So tan square A will be 9 upon 16. चलिए, यहाँ का LCM ढूंढिए. Find the LCM here. Whole upon 16. 1 और 16 का LCM 16. 16 और यहाँ 1. Okay. So 1 into 16 is 16. Minus 1 into 9 is 9. Then you have division sign. और next में यहाँ LCM 1 और 16 का LCM 16. 1 16 are 16 ones are 16 ones are 16 plus 1 9s are 9. So 16 minus 9 is 7 upon 16. Divide by, this is 25 upon 16. Convert division into multiplication. 7 upon 16 into 16 upon 25. 16 cancels. Therefore 7 upon 25. This is left hand side. Call it result number 2. So you got left hand side. What is the value of this left hand side? 7 upon 25. Now let's pick up right hand side and show that its value is also 7 upon 25. Alright. I'll pick up right hand side here. Okay. Now RHS, that is cos square A minus sin square A. Here you put the value, no children? So here you can say by 2. Sorry, by 1. 1 से result pick up here. Chalo, what is cos square? Yeah, cos is 4 upon 5. So cos square will be 16 upon 25. Minus sin is 3 upon 5. So sin square will be 9 upon 25. Lucky to have like denominators. 16 minus 9. That is 7 upon 25. So what is the right hand side? 7 upon 25. This is result 3. Straight away say, correct? By 2 and 3. It follows that left hand side is equal to right hand side. Prove. Clear? Understood, children? That's it. Alright, before I give you plenty of homework, let's see what we have learned so far in type 1. Type 1, you have to find either trigonometric ratios or value of expression or prove that type of sum is there. This is very easy, man. Okay. This is easier than finding the value of expression. Okay. Now, subtypes 1.1 to 1.7 we have seen. What is information given here? You are given two sides. And what you are asked to find? You are asked to find trigonometric ratios. Any two or all 6. Okay. Here, one side is given and one angle. And probably that is 30 degree, 45 degree or 60 degree. But this is case of trigonometric ratios of special angles. ये special angles में हमने जो किया वही करना होता है. So normally this won't be asked. Anyway, what you have to find? You have to find the trigonometric ratios. One side, one angle is given and you have to find trigonometric ratios. Type 3. What was given in type 3? One side and relationship. One side and relationship between any two sides. Any two sides. लेकिन this side is involved. This side, the given side is involved. And what you are supposed to find? Yeah, you have to find the value of expression. ये expression की value ढूंढनी थी. You have to find the value of expression. Okay. Here, one side is given and relationship is given. Relationship is given. But between remaining two sides, between remaining sides. Alright? The given side is not involved here. Your given side is involved. And you have to find the value of trigonometric ratio. भाई trigonometric ratio की value तो हर एक में ढूंढना है, expression की ढूंढना है, तभी भी ढूंढना है. Alright? चलिए. Type 1.5. What was that? Again, two sides. पहले जैसा. Two sides. But you have to find expression. Value of expression ढूंढना था. फिर, what was given in the next? What was given in the next? That is 1.6. Yes. Trigonometric ratio was given. Value of one trigonometric ratio was given. And you had to find the value of expression. And in the last one, again, the value of trigonometric ratio was given. Alright? I think somewhere we missed one. Alright? Okay. And you have to find, you have to prove the statement. You have to prove the statement. Alright? Anyway, you will understand this very well when you see the information and what you have to find. Now, the homework. Exercise 8.1, question number 1 to 10. The 11th one is true or false. You don't have to solve that because I don't think you are prepared for that. Alright? So, solve this exercise. Yes, after copying all this, you have to solve this exercise as well. So, you have got good job to do today. Alright? So, we meet again in the next session. Till then, goodbye.